The biggest thing you want is lead time on storm forecast, because that gives people a chance to evacuate and plan, and that just wasn't available in Sandy. So if we had better forecasts, people may have evacuated more quickly, but better prepared. We've been good at understanding the track of a hurricane relatively well, but what we haven't been good at forecasting is how strong that storm will be when it hits land. And we think part of that is because we don't know the ocean temperature under the hurricanes very well. Hurricanes live off the hot ocean surface. That's their energy source. The ocean has to be roughly 80 degrees or warmer for hurricanes to form and continue to strengthen. So you have to know how much warm water there is and how deep it is in order to know how much energy is going to be able to get into the hurricane to fuel it. The difficulty with predicting the intensity of a storm is we don't know a lot of the ocean temperature just because we don't observe it that often. We do get some data from satellites, like sea surface temperature, but that's only the very surface of the ocean, the upper few inches, basically. We don't know if that's warm water covering cool water, or if that's warm water covering more warm water. And if it's really cold water underneath a warm surface layer, that warm water will mix down to the cold water. The ocean surface will then be cooler, and you kill the hurricane because now it doesn't have as much heat to live off of. The assets that measure the ocean on a routine basis, profiling instruments, they measure temperature and salinity, but they only profile once every 10 days, and they're very widely spaced. So for hurricane research, it's a very coarse view of the ocean. After Hurricane Sandy, there was funding approved by Congress to help improve hurricane forecasting. So we got funded to make more ocean measurements, and the easiest way to do that was to get floats in front of the storms. Oceanographic ships are very rare in the ocean, and they avoid hurricanes because hurricanes tend to sink ships. So you don't send ships into hurricanes. The only assets that go near a hurricane is an aircraft, the hurricane hunters. The Air Force has a squadron of 10 planes that their sole mission is to fly into hurricanes, to measure the strength of the winds and to find the location of the center. Their data gets fed back to the National Hurricane Center for forecasting. The floats we normally use are about 50 pounds. They're pretty big. In order to be able to get them out of the plane, they have to fit through a tube that's about 5 inches in diameter. So to do that, we had to make the bigger profiling float smaller, about half the dimensions of a normal size float that we usually use. So we had to take all the mechanicals of the larger floats and scale them down into a smaller form. The hurricane hunters provided us the opportunity to fly with them to deploy the profiling floats in the storms. If a storm comes up, you only have a day's notice basically to get to where you need to be to start flying the storm. I keep all my stuff that needs to go on storm flights in a big pile ready to go because I could be leaving the next day. Buy a plane ticket and you go. So flying on the Hurricane Hunter planes, it's pretty loud and it's often not very turbulent at all. Partly because they avoid the worst turbulence. The planes are built for this mission, so they're strong. You just fly through. I've hit worse turbulence on a commercial aircraft. So usually we fly at 10,000 feet, and it's pretty cloudy at 10,000 feet. In like a strong storm like Irma, you can actually see the eye wall itself. So there's a vertical wall of clouds. I've done about over 60 flights in the storms, and I've done 44 eye wall penetrations. The new float we developed is the air-launched autonomous micro-observer. Air-launched because we can drop it out of a plane, micro because it's smaller, autonomous just because it works on its own. So when the float's launched from the airplane, a parachute gets pulled out. When it hits the ocean, the float starts sinking, and when it hits a certain depth, it turns on, starts it in its cycle, and so then it sinks down. Then on the way up to the surface, it measures temperature. When it gets to the surface, it sends back the data it just measured. We get the data back here and send it out to the forecasters at the Hurricane Center in real time to help improve the forecast. This year, we used the floats during Irma and Jose. So the hope is to improve the hurricane forecast so that you know how strong a storm is going to be, and that helps you figure out what areas of the coast to evacuate, how many people to evacuate, what to prepare for. The data we get from the hurricane floats has a direct impact